Okay.
So our topic in our group project is characterizing uncertainty through expert elicitation. Expert elicitation addresses risk when desired knowledge and/or data is non-existent or unavailable. Scientific and technical judgments from experts in the form of subjective probability distributions are used to support public policy decision-making. Expert elicitation is utilized to characterize uncertainty that results from the lack of knowledge or data. However, it does not create knowledge or data, rather provides judgment. Subjective probability is relying upon a number of heuristics and biases. Expert elicitation can be divided into two categories: informal elicitations, when the risk assessor decides values, uses causal elicitation without structured efforts to control biases, and it's more common for routine decision making. It's suitable for non-instrumental relevant quantities. Formal elicitation is when critical variables with high visibility and controversial analyses can affect decision-making in instrumental quantities. So a personal opinion, professional opinion, and expert judgment. Personal opinion is a view or judgment formed about something based on an individual's experience. It can be used for non-instrumental uncertainties. A professional opinion is a view or judgment formed about something by a person that is engaged in a profession that is not necessarily based on fact or knowledge. Expert judgment, this is a person who has comprehensive authoritative knowledge of a skill in a particular area. A decision or a sensible conclusion is reached by that person with comprehensive knowledge in that area, and it's considered preferable to a professional opinion and personal opinion. So these are the expert elicitation parameters. This includes lack of data and knowledge about instrumental quantities, when the problem is complex and highly visible, when there's a lack of trust in analytical work, when the risk assessment will provide a basis for public decision-making, when the risk assessment will provide a basis for a formal rule or regulation affecting an industry, when the organization has stewardship responsibility for public value, when values are a conflict or an issue, when the issue is controversial, when one or more stakeholders is likely to challenge the decision, and when human health, life, safety is affected by that decision.
Subjective probability distributions. This section presents the idea that expert elicitation is a statement of an individual's beliefs. These statements are comprised of a few different aspects. They are comprised of experts' subjective or personal probability, which is broken down into factual knowledge and a general subject knowledge that can either be self-expressed or elicited. The process of eliciting these subjective probabilities is where the bulk of this section revolves. For instance, all subjective probabilities are based on formal and coherent/consistent metrics, and the process of actually eliciting these responses can determine the validity of. This is important because the purpose of eliciting responses is consistency. The elicitation protocol. This section discusses the protocol for determining the experts and eliciting responses that are not extremely biased. As humans, we often cannot conceptualize probabilities on a small scale. It is often best to use these elicitation techniques to allow them to be the most useful. In most cases, it's ideal to interview using questionnaires. Through interviewing, it allows for clear communication. In the context of an interview, there are 3 examples given in the text. While they have slight differences, the similarities that exist are primarily in the process of motivation, structuring, and judgment. The process of motivation typically entails the building of a rapport. Structuring often includes exploring the knowledge the expert presently possesses and providing an unambiguous framework. The last step is testing the response for consistency. Multiple experts. This section explores the concept of multiple experts convening on a topic of probability. It reflects the pitfall of collaborative work when there are multiple experts, often bogged down when decision-making desire to have a consensus on a complex topic can lead to stagnation. It also explains that a desire for consensus for the sake of performing a task can often be mistaken for certainty. It presents the idea that ambiguity is fine and individual experts can determine their distributions, then reflect on their findings as a whole and determine if their distributions produced a vastly different result. Ideally, there is no reason to combine expert assessments if you do not need to. After reflecting as a group, they can determine the differences in their distribution and alter them, retest, and then repeat the cycle.
So eliciting subjective probability distributions. This refers to obtaining an individual's belief or opinions about the likelihood or probability that certain events or outcomes based on their subjective judgment and/or personal experience. Since probability assessments can vary based on an individual's perception and cognitive biases, we must use surveys, interviews, and decision-making tasks to capture these subjective beliefs. We can use several techniques, including direct probability assessment, probability ranking, probability matching, and calibration questions. In direct probability assessment, we ask individuals to provide their estimates of probabilities, such as assigning a probability value to an event or outcome. Probability ranking involves asking individuals to rank different events or products based on their perceived chances relative to each other. Probability matching requires individuals to match their estimates to predefined probabilities, while calibration questions help us calibrate their subjective probability assessments. Eliciting subjective probability distributions can be helpful in various fields, such as decision-making, risk assessment, forecasting, and policy-making. However, it is essential to acknowledge that subjective probability assessments are inherently subjective and can be influenced by cognitive biases, emotions, and personal experiences. When interpreting and using the results obtained from these methods, it's crucial to consider their limitations and potential biases associated with subjective probability assessments. Consulting with experts, using multiple scenarios, and comparing subjective assessments with objective data can help improve the reliability and validity of eliciting subjective probability distributions. When done carefully and cautiously, eliciting subjective probability distributions can provide valuable insights into individuals' beliefs and perceptions about certain events, which can inform decision-making and policy formulation processes. First, overconfidence is the tendency to overestimate the accuracy of our judgments or predictions. We can use calibration exercises to counteract this bias and decompose problems into more specific components. Additionally, it's helpful to question the sources of information and whether they are fact-based or opinions. Second, availability bias refers to relying on readily accessible information instead of seeking all relevant information when making judgments. To neutralize this bias, be aware of it, avoid looking at information chronologically, and examine trends from different angles. Extend your time frame, investigate the history of similar events, consult broader evidence, and question commonly accepted views. Finally, the representativeness heuristic encompasses several biases, including the conjunction fallacy, base rate neglect, the law of small numbers, the confusion of the inverse, and confounding variables. These biases can lead to judgments based on stereotypes, generalizations, or limited data. Additional cognitive biases can affect our judgment and decision-making processes. These biases include anchoring and adjustment, motivational bias, confirmation bias, and framing bias. Anchoring and adjustment are the tendencies to rely too heavily on an initial value when making judgments or estimates. To reduce this bias, avoid embedding anchors in questions, explore a quantity's upper and lower limits, allow time for reasoning, and practice absolute thinking instead of relative thinking. Motivational bias arises from our underlying motivations and desires, which can lead us to overvalue or undervalue information. So be aware of your motivations when making judgments and strive to be objective and balanced in your assessments. Confirmation bias involves seeking information confirming our pre-existing beliefs while discounting or ignoring contradictory evidence. To counteract this bias, actively seek out diverse perspectives and challenge your assumptions. Lastly, the framing bias occurs when people make different judgments based on how information is presented rather than the content itself. Be mindful of how information is framed and consider the content before making decisions. Understanding these cognitive biases is crucial when making uncertain judgments. By being aware of these biases and adopting strategies to counteract them, we can improve our decision-making processes and reduce the likelihood of making biased judgments. Calibration. So this is a strength or weakness of elicitation, which rises and falls with the process and with experts. So experts who are overconfident overestimate the actual frequency of events in their subjective probabilities. Underconfidence is when you underestimate the actual frequency of events and subjective probabilities. Experts can be calibrated to learn how to recognize and evaluate their uncertainties. There are three general styles of calibration. The first one relies on asking a large number or a variety of questions to test an expert's confidence in the correctness of answers. Experts will express the likelihood that their answer is correct. And then there's binary calibration. So this is a series of true or false questions that experts must answer, and they have to identify their confidence that the answer is correct. The total of all the percentages is then converted into a decimal to identify the expected number of correct answers. If the expert estimates that questions with a confidence interval of 90%, a well-calibrated expert will get 90% of the answers within their interval estimates. When the confidence interval is fewer than 90% or less than 90%, it means that they're overconfident. If it's more than 90%, then it means that they are underconfident. Lastly, for the summary, subjective probability can be useful in data gaps. It's used when you do not have all the data you wish you had to conduct a risk assessment, and you do not always have the luxury or time to commission research. Not every subjective probability estimate warrants a formal elicitation, so it's important to use elicitation techniques that can limit the consequence of heuristics. It's often utilized in the Monte Carlo process to see how expert elicitation is utilized. It's also utilized in probability distributions and simulations, in analytical calculations for risk assessment and understanding uncertainty. And these are our references.